All right. Good evening, everybody. So on with it. We are having class on a Saturday evening here for the very simple fact that. By the way, can I ask that we please get confirmation on whether you can hear me just fine? Okay, beautiful. Thank you very much. So we are having class today on a Saturday evening because apparently I got a request from the course representatives, um, a request for us to not have class on Thursday, apparently because there are some of you that had, is it colleagues or something that were quote unquote graduating, and so you wanted to follow along with the apparently proceedings virtually, and some of you apparently wanted to, excuse me, wanted to attend the graduation ceremony that was taking place on Thursday and on Friday. And so I had to capitulate, right? It said, it's okay. Let's give them an opportunity to do precisely that. But I'm very wary of what is happening. Usually, I don't like rushing through or missing crucial aspects of whatever course I may be teaching at any given point in time. And so I did not want us to essentially lose out on 2 hours ideally. And unfortunately for us, tomorrow is a holiday, so we're obviously not going to have class tomorrow, so figured we would have class today instead. Okay. In any case, we're going to continue our discussion. We really haven't even started scratching the surface here. So in the last interaction that we had, we essentially started looking at a set of tools and technologies that we're going to be using in the course. And I did mention the fact that the best technology that we're going to be using is a Python programming language, ideally. Okay. This is it's a Python, programming language, ideally. I don't know why this thing is saying upcoming instead of streaming. I'm sure it will start anyways. And so what we essentially started doing we met last time is we started looking at quote unquote Jupyter notebooks. So we had a discussion of Jupyter notebooks, and I believe we had gotten to a stage where this is a part where sometimes I lose track of what exactly it is would have been doing really, but we got to a stage where we started discussing Google Colab, I believe it was. Well, we're discussing Markdown, not Google Colab. Google Colab, but then we started discussing, Markdown. So this notion that when you are constructing or implementing your typical pipeline as it relates to data mining, you would ideally want to make sure that what you're doing is reproducible, is it? And so we discovered that one of the easiest ways, one of the sure ways of doing this is you use what's called a notebook. Okay. And so we realized that in a notebook, documentation is crucial, so providing descriptive information about the range of things that may potentially be taking place, or the range of things that you've been implementing, including your pipeline. Don't document those things, right? So you provide this documentation in the form of quote unquote Markdown. Okay. It's not a very Markdown is it's a markup language similar to HTML. In fact, it's the reason why when we're going through things like enumerations, so ordered list, I was actually making reference to, if you remember, I was making reference to HTML, right? So your typical list in HTML will be constructed using like an ordered list. Bullets will be constructed by using the UL tag, is it? An ordered list, right? Because there's no order. So it's an ordered. So you do a URL, and then inside the URL, you have these nested tags, the list tags, this is the LI tags, ideally. And we discovered that when you're dealing with Markdown, what you do is use asterisk, right? I've just shared the direct YouTube live URL. Please share that with your colleagues. Those that will, I know what this is here. Those that will have difficulties, do this later on. Those that will have difficulties attending the Google Meet session. And so there was that, right? What I'm referring to here, colleagues, for those of you that are lost, is quite simple, right? In HTML, your bullet points would be constructed using the URL tag, right? And then inside the URL tag, you would have the list tags, right? If you remember HTML, I don't know how much of this you remember here. And then your ordered list rather, would be constructed using the OIL, right? So we realized that in Markdown, it's quite simple, really. What you do is for the ordered list, you just use Arabic numerals, right? So you just have the one followed by the text that you want to add here, right? The syntax is you have the enumeration, that Arabic numeral, followed by the dot, right? And then everything else is going to be done for you behind the scenes. Whereas for an ordered list, what you do is you can just use asterisk as ideally, and then have the text again, right? There are a couple of other things. I did direct you to the documentation that is available on the Google Collaboratory, right? The examples that are there. There's a series of other tags that you may probably find yourself using. Like, for instance, just going to open this so that it's a lot easier for us to. Like, for instance, links, is it? If you remember, I don't know if we talk about links in here, but if you remember, in your HTML, links would be specified in such a way that you use the add tag, is it? I don't know if you guys remember this, right? If you want to create a link in HTML, use the add, right? Then you have your href or something like that, right? Href, there are a couple of other things that you can provide here, right? The target, for instance, parameter and all those things. But what's crucial is that you use the link, right? Anchor, and then you specify the URL as a string, right? So the value associated with the key href, right? So if you wanted to link to Unza, for instance, would include this here. Well, it turns out that in Markdown, what you do for you to replicate the same behavior, ideally, is it's quite simple. Really, it's not not really complex, but it's not as verbose as HTML, right? All you do is you would specify the text in square brackets, right? So I'd say in this particular case, if you wanted this to be UNZ, I would just say University of Zambia, like so, right? And then this would automatically become a hyperlink, is it? If you remember this, right? Well, in Markdown, what you do is you have a square bracket, and you put the text that you want to appear, right? As the link text, in this case, then you have the parentheses right after the square bracket. So it's the URL itself, so something like this. So quite simple stuff. And you want to try these things out on your own, right? Try and see if they work. Trying them out is not that difficult. All you do is the easiest way of doing this is if you have access to the internet, is you'd use Google Colab, right? And you'd use Google Colab. No, you'd use Google Colab, and then within Google Colab, all you have to do is you make sure that the text that you're experimenting with is Markdown, right? The default cell, it turns out, is usually a code cell. So if you want to render markup, what you want to do is you want to make sure that you specify that you're dealing with Markdown. I don't know why this is taking a while to load here. What I'm going to do is I'm just going to switch to my other connection here, because I notice that my Liquid Telco connection seemingly is problematic here. Just bear with me. And hopefully this is working just fine. Yes, beautiful. So what I mean is, by default, right? If you look at this notebook that I've created here, by default, there's a cell, is it, that is going to be activated by default. This thing here, this is a code cell, right? You notice here, when you start coding or something like that, right? Incidentally, you know, this is integrated with one of the it should be, is it Gemini or something? It's integrated with Gemini, so you can get access to the things that you typically do when you're using Gemini chatbot, ideally, right? So you can automatically generate code and all those things. So you want to make sure that this thing here is changed from code to text cell. It has to be a text cell. So in this particular case, you'd create a cell like this. Then if you wanted to experiment with the University of Zambia, this is what I did. University of Zambia. The University of Zambia is the largest university in Zambia, something like that, right? So what you do for this to actually work is you would do this, right? What I mean, unza.zl. Then when you render this, the hyperlink will appear like so. Yeah, so the usual stuff, really. Not too complex, but you know, something worth knowing nonetheless, I guess. So there's that. But it turns out, right, one of the true powers, I guess, when it comes to using or leveraging notebooks is you can actually integrate other languages, okay? Or you can write code, right? Using other languages, so you're not really necessarily restricted to Python, ideally. All right. So there are quote unquote, for instance, instances where you may want to maybe integrate, you know, shell commands, right? And I'm using this as an example because my base operating system is almost always a Linux-like operating system, right? So I use Ubuntu ideally. So there's that, and it turns out that for you to be able to do that, you can take advantage of what are called magics, right? So in essence, what you do is you'd specify these, obviously, these cell magic commands within the code cells, right? But it turns out that the syntax that you use is somewhat different. You know how when you're wanting to write it's a Python code, for instance. Let's do this here, and so much commands, something like that. When you're wanting to specify, Python code, all you do is you specify the Python code within a code cell, right? So, like in this particular case, I could say I just want to print the result of adding 2026 plus 1 because, we are graduating next year, right? So that I get 2027 as the answer. This works quite fine, right? But when you're wanting to use these other languages, right? Or if you want to script using other languages, like for instance, you want to specify shell scripts, it turns out that you can use cell magic, right? And the way that you work with quote unquote shell commands, for instance, is you prefix a command with an exclamation mark. Okay, but there's more that you can do, it turns out. And I think I'm just going to start off by showcasing the more part, although we rarely focus on that, right? Usually the examples that I give in this course would mostly include some shell scripts, not too detailed things. I don't use fancy things that I normally use on a regular basis, like awk, for instance, or sed, but I'll just use like basic bash, commands ideally. But it turns out that you can actually check or have a sense of the different sort of things that you can do insofar as cell magics are concerned by issuing the ls magic command, right? So if you run this in a code cell, it's going to list the different sort of things that you can do here. Now, it's quite interesting, really, because what you begin to notice is that there's a whole range of things that you can, I don't know why this is the thing here, that you can, a series of like commands that you can run within a typical notebook. Okay, so what you're seeing here, right, that there are so-called line magics that you can use, and then also you have, if you scroll down all the way here, you have access to actual specific cell magics, right? So commands that will allow you to kind of run multi-line commands. Okay, so I'm going to start off with some examples of let's say, I'm just going to scroll down here, examples of, let's say, using or running bash, executing bash commands, right within your notebook. If I'm on my operating system like here, right, let's say I'm wanting to explore what is in the this thing here, this folder associated with the course, of course, and I'm just going to do the source here. I prefer to do this because I'm going to be context switching, right? There are a couple of things that I can do, right? If I'm running these commands right on the operating system, I may be interested in checking how much space, for instance, the files in this folder are occupying on disk. I may, for instance, want to check the current directory, so I'll do a pwd, right, present working directory, or I may want to list the things, the files, right? So regular files and directories in this particular what do you call this? In this particular directory associated with the course, or I may want to kind of like check how much space has been occupied by different subdirectories in this folder. So something like this, right? I'm running these commands on my local operating system, right? But it turns out that if I'm using a notebook, I can do exactly what I was doing, right? So for instance, if I wanted to check the current directory I'm in, right, I'll just use exclamation mark, right? And then I'll do a pwd, same command, present working directory, right? And then what this is going to show me is going to show me that the current directory I'm in is called /content. Now, in case you're wondering, well, Lighton, why is it that the output when I'm running this command on my operating system is different from when I'm using Google Colab? Well, the reason is simple, right? The reason is that I'm running this command on Google Colab. So in essence, the current directory that is being presented on my behalf is actually associated with the operating system linked to Google Colab, if that is making sense. If I wanted to render things as they appear on my current operating system, what I would have to do is I would have to run, right? I would have to run either Jupyter Notebook or Jupyter Lab, okay? And then use whatever notebook I would open here to run these commands. And then I'll be able to see the same exact things that I'm seeing on my local OS, if this is making sense, right? So this is the only way to work. So the reason why the output looks slightly different here is because I'm running these bash commands on Google Colab, right? It's like a, and the way Google Colab works really is that, I don't know if I haven't made mention of that here, but the way Google Colab works is that behind the scenes, what is happening is there's an Ubuntu operating system a virtual appliance, really, if you will, that is activated, right? So everything you're doing is being done within the sandbox, which really is an Ubuntu-based operating system. Okay, and then that should probably lead you down the path where you're asking questions like, well, how do we know this, right? Well, you can also run, if you remember your operating system, right? You can also run commands like lsb release or something, right? To try and check the version of Ubuntu you're running. So if I go on Google Colab, I'm Google Colab right now, right? If we go on Google Colab and I run the command, right? Exclamation mark followed by lsb release -a, I'll be able to see the version of Ubuntu on Google Colab. So you notice that the operating system I'm using, right? When I'm using Google Colab here is version 22.04.5, right? Whereas this is Jammy, is it? Whereas the one I'm using on my local machine is 24, right? Noble. If this is making sense. So two different releases. Of course, all of them associated with long-term support, LTS, right? Hope this is making sense here. So it's quite useful, right? Because it turns out that when, imagine you're working with a data file, right? You haven't really gotten to a stage where you want to ingest that file into, let's say, a Pandas data frame, right? One of the things that you can immediately do is you can start running these shell commands, is it? So you get to, I don't know why this is not working here, but you start running these commands, right? So copy these things here from. You'd run these shell commands to maybe try and inspect or attempt to inspect the these data sets that you'd be working with. So in this particular case, I guess I'm going to just change this so that it's not confusing. So for this for 2, and then something like that. So one of the things you'd want to do is you say, well, I want to maybe inspect this data set, right? How do I do this? Well, I'll run the more command to just view it. I can do cat on this, right? I can run the cat command, right? I don't know why this is not working here. I can run the cat command, right, to just so that I get to see the lines, right, associated with the data that I'm working with here. You know, I can even run like awk or something like that, right? And this becomes tremendously useful because at some prior to ingesting the data into a Pandas data frame, one of the things you have to do is you want to make sure that the things that you are wanting to ingest here are the correct things, right? So you do some sort of like preliminary inspection of the data. So really any shell command that you can think about can be executed, which is quite useful if you ask me. In addition, there are other, and in case people are wondering, well, what about the running these same commands using Jupyter Lab in this particular case? So same syntax, / pwd, but this time around I'll be seeing the output as I was seeing it when I was running these commands using my terminal application, right? So you notice here, right, that this notebook has been created in this directory here, right? So this is the absolute path right here. I can do things like I want to check how much space is associated with the directory. I can check the I can check the space occupied by the different subdirectories, right? So I see here that I have these different subdirectories. There's slides, there's playground, there's .venv, which is obviously hidden directory, right? And then there's also a .ipynb _ checkpoints, right? Again, a hidden directory. This is typically automatically created when you activate Jupyter Lab or Jupyter Notebook, right? You remember hidden folders from your operating system. So if I do a list here, if I do a list, right, you notice how I only see playground and slides, is it? But if I do a list minus A, I'll even see those, what do you call this? The hidden directories, right? You create a hidden directory in Linux like operating system, if you remember from 2202, by making sure that it's prefixed with a dot. So anything prefixed by a dot is a hidden directory. Okay. So you can run these things right within LSB release, right within your notebook, right? Locally as well. Quite useful. In fact, the same command I ran here, the ls magic, that allows you to see the different sort of line magics and kind of like cell magics that you can run. You can check them as well right within Jupyter Lab in this particular case, right? So notice these are the line magics that you can play around with, and then these would be your cell magics, right? Multi-line commands. And it's quite interesting here, right? I don't know if you see where all of this is going here. You can write JavaScript code, right within your notebook. So I'll come here and I could say, well, I want to see if I can JavaScript commands or something. And the only JavaScript command I can think of that would probably help exemplify this is the alert, right? And do alert. I think it should work here. And then I'll say JavaScript within a notebook. Right? JavaScript commands within a notebook. But of course, the way you use this here for if you're wanting to execute JavaScript code, right? This is the command that you use, right? JavaScript. It has to be the very first line. Yeah. And for the cell magics, what you do is you make sure that you have two percentage signs followed by the command. So this is like JavaScript. If I run this, it's going to be hopefully an alert that will pop up somewhere. I don't know if it will pop up. You see this here, right? JavaScript within notebook right up here. What else is there? Well, you notice that it's not just JavaScript, right? If you want to render LaTeX, for whatever reason here, LaTeX commands, right? You can write them from within here. I don't know if you've been introduced to LaTeX, but LaTeX is all about what do you call this? LaTeX is if I can, I don't know if I have my LaTeX is CV. LaTeX is about something. I don't know where this is coming from here. I know I should have it somewhere. I don't know where it is. I think it's in academics or something like that. So LaTeX is what LaTeX does is let's say something. So the idea behind LaTeX is you can typeset, is it? You know how typically when you're constructing a long document or a document, what you do is you use a word processor, right? Well, there are instances where you may want high quality output, right, for your documents. So you use what's called LaTeX, right? LaTeX. I don't know if you know about this. So you typeset, okay? And the way you typeset really is against the markup language. So in this particular case, I have an example, I guess. It's, just trying to make sure I have different versions of this. I think it's this. So you use it's a markup language, right? So you use tags ideally for you to kind of specify content and the structure. And what you begin to realize is that the quality, for those, I don't know if you've been introduced to LaTeX, if you look at the quality of the typical LaTeX, document, it's really high quality document, right? Really high quality document. You have control over the type of fonts you want to use. I love LaTeX. Although, I mean, I don't use it as often as I used to, but when we were publishing, like recently, I think, and I'm showcasing this because when you're writing your documents, one of the things that you guys may want to do is you probably may want to typeset your final report, right? So give you an example of something in this we've been doing here. PDF, right? All of this is typeset using LaTeX, this publication, yeah. If this is making sense. I'm gonna pause here. I think there's a, I guess Miss Deborah. Oh, saying the live stream has been, you have your hand up? Please, you wanna unmute yourself, I guess? I think you can unmute yourself.
Yes, I've received a message from one of the students saying that the YouTube live stream has been cut off.
Yeah, why don't they want to attend? I wonder why they don't want to attend. It's like, why don't you want to attend the um, uh, the class, right? Don't know why. Let me just try and verify here. I know what that is all about here. It's unfortunate. This thing seems to suggest that, oh, it says I'm offline here. Okay. You should not stop and then I'll restart. I guess it's, I shouldn't have stopped here. I think it's probably because I need to authenticate myself or something. It's a bit weird here. You want to encourage your colleagues that it turns out that we can, right? Google Meet, unless if they're having challenges here. I think I've managed to find a solution to the problem associated with horrible stuff. Problem associated with the 100 participants limit, right? If that kind of makes sense. I think things had stopped because start streaming again. I think it had stopped streaming because I was kind of offline. Just do this and just the Python reminding or something. Yeah, hope this is kind of making sense. I don't know as I'm doing this. I don't know if people have any specific questions about, the stuff we are talking about here, right? Which is Excel magics. Quite useful, I guess. I don't know. I certainly find them very, very useful myself. I don't know about you guys. The thing is telling me to log in again. I don't know what this is all about. Okay. I don't know why it keeps telling me to verify that I am me. I think because I'm linking. Okay, so you if you can maybe confirm once I'm able to do this, I'd greatly appreciate it, Ms. Deborah, the people that online or something. Anyways, so I was just showcasing, right, the fact that you can run LaTeX commands, right? For whatever reason, if you want to, if you're generating vector graphics, and I imagine instances or use cases where you may want to write code that's going to generate, these vector graphics, right? SVG. For those of you that were doing graphics, computer graphics and visual computing, you know what I'm talking about here, right? So you can, whatever things that you add into your .svg file, you can actually render, right? In a cell, in a code cell. What else? Yep. I don't know if that's feedback. Hopefully they're able to connect now. I don't know. Miss Deborah or Mr. Humphrey. Don't know. Yeah. So what else, right? I'm gonna scroll down here. You notice here that you can actually even write HTML code, right? So if for whatever reason, if you want to render HTML, right? In an ideal case, if I wanted to render the same code I had here, right, where I want to just include a hyperlink code, if I'm just going to copy paste the code I had here. If I want to render this in a notebook, right? If I render this in a code cell, this won't work, right? It will be an error, right? Because by default, I'm using Python kernel, right? If I render this as part of a Markdown text text cell like this, and I execute this, it will fail, right? Well, I guess it's looks like it's working here, which is a bit weird here. I don't know if Google Colab has sort of like changed things here. But what about if I wanted to render this, if this, testing 1 or something. And it's going to have testing 2 or something like that. And up there, things have changed slightly. Okay, it's working. But I don't know if all of the HTML code is actually recognized now. I don't know if this is specific to, this could be a Google Colab thing. It's a way of checking, right? We can come here and change this into Markdown text, right? And try and render this. Okay, it's working as well. But just note that you can actually also use the cell magics, right? The HTML cell magic idea. This, right? So what you would actually do if at all some HTML code fails, right? Some tags fail, you just have like a HTML, so right, and then you'll be able to execute this and should be able to work again. And of course, you want to make sure that this changes to a code cell, right? This is the only way this should be executed ideally, right? If this makes sense. I don't know why this is again not working here, but don't know. Okay. So you can also execute things like Perl, right? If you have some complex bash script that spans multiple lines, for instance, you can use the bash cell magic ideal as well. All right, I guess this is kind of making sense, I hope. Okay. Have you been able to confirm if these guys are now able to? I think I'm streaming. Don't know. I hope. Don't know. Okay. Can you hear me, by the way? Thumbs up if you can hear me or something. Yeah, okay. You have to stop. Yeah, so there's that, right? So I hope this is making sense here, right? And I don't know to what extent you're going to find yourselves using these cell magics. Right? There are a couple of other things that you see me use, like if you want to time certain code constructs within your cell, there are certain things that will take a long time to execute, right? I've worked on problems with students where you're running a command or you're running a particular segment of your notebook and it's taking minutes, right? What you want to do is you can use the time command ideally, right? To time that particular cell. And probably once you have a sense of how long it takes to execute that, you can add a comment so that if you find yourself running that particular segment of the notebook in the future, or if somebody else wants to rerun what it is you did, they shouldn't think that there's something wrong with the notebook, right? And in fact, you would use this sort of technique to identify which portions of the notebooks you'd want to freeze in time, right? So you can pickle certain things that you're doing, right? You encapsulate them so that they're frozen in time. Anyways, hopefully this is kind of like making sense. What else? Well, we see here that we include textual content using Markdown, and then we have live code, which primarily is specified using Python commands, but also we can run other commands. We can run other commands like shell commands, for instance, Perl code, JavaScript code, and all those things, if you need to do that. And you notice that depending on your background, sometimes you probably would have strengths in other types of languages that you'd want to incorporate into whatever it is you're doing, right? So you don't necessarily have to restrict yourself to just exclusively using Python, okay? Anyway, so you can also add visualizations, and adding visualizations simply means you are probably using libraries like Markdown, right? So you're using libraries like Markdown. Libraries like Matplotlib or Seaborn, right? So again, it's Python code, but you'd be using specific, let's say visualizations here. You'd be using specific libraries, right? So you do something like import from Matplotlib, lib import use the pyplot as PLT or something like that, right? Import your library, and then what you do is you'd say, what I want to do is I want to plot, right? There's even an example here. Wonderful, is it? Life has become so much easier, right? Life has become so much easier now. You can literally automatically generate stuff here. So you can incorporate visualization. The typical visualizations, at least in 4097s, or visualizations are primarily going to be constructed using the Matplotlib library, right? So it's a graphing library, one of the most widely used graphing libraries. But of course, there are others that you can use. Like if you want graphs that are aesthetically pleasing, you'd probably want to gravitate more towards Seaborn, right? We'll talk more about this. I think there's a very brief segment in this particular lecture series where I talk about Matplotlib really, right? Just briefly. So it's Seaborn, right? There's a dedicated website, and there's some really nice sample. There's some really nice sample graphs that give you an idea of what sort of visualizations you can actually construct, right? Using so for Matplotlib, you go to examples here, and you have a sense of the real power of Matplotlib. Sure, you can construct these using Excel, some of these graphs using Excel, but there's some complex things here, like subplots that are really difficult to replicate using your typical spreadsheet application, right? So you need a dedicated library. But also, in our case, remember, we are constructing a pipeline, right? So we want this pipeline to be encapsulated into one thing, which is our notebook, right? So we have our scripts that are harvesting data somewhere. After we harvest the data, we want to visualize the data. We use, Matplotlib or Seaborn or something, or Plotlib, the number of graphing libraries. During evaluation of our models, we want to generate graphs, right, to showcase the performance of the model, for instance, or different feature combinations. Use Matplotlib, right? And incidentally, in this particular paper, which is titled one of the datasets, right, it's currently still under review here, there's some graphs that we've generated in here, right? Some simple graphs. We'll start here. Yes. Some of the graphs are simple, right? Like this, horizontal bar plot, nothing complex, nothing too complex about this. Some are somewhat complex-ish, right? We have a subplot here, right? Distribution plot, right? But we have like 4 different plots, right? What else do we have here? Well, horizontal bar plot, okay, representing Likert-like scale responses, right? Strongly agree. This is, strongly disagree here, right? You have a scatter plot showcasing clustering, right? Yeah, all of these things, okay? All of these things are constructed using Matplotlib and Seaborn. All of these things, including this heat map here, right? This is Matplotlib at work. Matplotlib at work, right? This confusion matrix here, constructed using Matplotlib. Yeah. Anyways, so it gives you an idea of just the true power of Matplotlib. Also, but in the within the context of what we're discussing right now, it gives you an idea of what sort of visualizations you can actually generate, right? Using notebooks. All of these things can be generated within Notebook. All right. Hope this is making sense here. Incidentally, what you're seeing, this is an example. This was not really generated using Notebook. I mean, a Notebook or Matplotlib. This was generated using a plugin in Google Sheets, because I was collaborating with people that don't know how to use, Matplotlib and all that, right? So it was a lot easier for us to just use Google Docs and Google Sheets ideally. Okay. All right. So again, if you want to have a sense of what is possible when it comes to Markdown, there's a Markdown guide available within Google Colab, right? So when you go to colab.research.google.com, you have access to a whole slew of examples. Now, I wanted to spend a little bit of time discussing this Google Colab interface, right? Because it turns out that in as much as you can use Jupyter Lab or Jupyter Notebook, okay, for you to construct this notebook. My advice to you is you want to make sure you try as much as possible to use Google Colab. And the reason is simple, right? In all likelihood, well, not in all likelihood, in your respective projects for the project teams, you are working with 4 other people, right? So the question you're asking yourself, or you should be asking yourself, is how exactly are we going to seamlessly collaborate with each other? Okay, I mean, you can take the traditional approach where you are committing changes to a notebook, and then once you commit your changes, you push them to this central repository that all your team members have access to. That is fine, and in fact, I think in one of the assignments, it would be a requirement for you to include commit messages for the different things we're going to be doing. But it turns out that Google Colab has a lot of advantages, right? Backups are being done for you automatically, right? You will always have access to the notebook, right? On the go, literally. You remember the Google Colab, application that's colab.research.google.com is a progressive web application, is it? So if you render it on a mobile device, if you remember the example I gave last time, the interface is adaptive like that, right? I mean, sure, it's a bit cumbersome for you to do certain things because you're twiddling with your thumbs, but you get the point. So I want to talk about the interface here, right? And the way you get to the interface, obviously, is you go to colab.research.google.com. What you immediately notice from the interface is that there are some similarities, like glaring similarities between the Google Colab interface when you compare it with Jupyter Lab or Jupyter Notebooks, right? So what you're seeing here is the interface for Jupyter Lab, right? You have your menu item. Of course, there are other things here that that you have access to, things that will allow you to install plugins, right, associated with Jupyter Lab. There's a way of renaming files. You have this panel that kind of presents some file browser, if you will. Is it? What else is there? You can check the kernels, right, that are currently running. Like in this particular case, you can expand this and you notice which specific kernels are running. You can see the structure of the document that you're constructing, is it, by looking at the table of contents. So if we were carefully constructing this from within here, using those Markdown tags, like heading 1, right? They would be constructed on our behalf. You notice what's happening in the table of contents here. They say heading 1. I run this and I come here and I say heading 2. And I make sure that I change this to Markdown. And I run this. My table of contents is being constructed on my behalf here. So if I context switch and go to Jupyter, Google Colab, you notice that the interface is somewhat similar. Not exactly the same, but somewhat similar, right? This vertical panel here, it's menu item that you have here, right? Table of contents, is it, right? There's a file browser, these menu items that you have access to. And because they're the same here, it turns out that life is a lot easier when you're transitioning from, or you're context switching from Jupyter Lab or Jupyter Notebook to Google Colab, because they're doing more or less the same things, right? But there are a few other things that you want to be aware of. So first, in terms of the menu item, if you look at the menu item, the file, menu item will allow you to do a whole range of things, right? Like you can explore things. If you've integrated Google Colab with your Google Drive, you can actually navigate through your Google Drive directories, ideally, right? You can rename the file, the usual stuff, right? You can copy this, because right now you're working within the Colab application. You can copy this to Drive, Google Drive, right? If you've linked the two, okay? You can actually connect your GitHub account to Google Colab, right? So that the things that you're doing in here can actually be saved into whatever repository you'd have created in GitHub, ideally. And my personal favorite, it turns out that you can download, right? You can download this file as an interactive Python notebook. And why is this important? Well, it turns out this is important because if I can download this as an interactive Python notebook, what this means, if I download this to my local machine, I can then, gain access to this file here that I've downloaded using JupyterLab or Jupyter Notebook. Right, so you notice here that there's a back and forth, is it? If I'm making changes to a notebook locally using JupyterLab, all I do is I upload this .ipynb file, right, into Google Colab. I can import it. If I'm working in Google Colab and I want to make sure that I'm able to work locally, what I do is I go to File and then I download the file. Right, so it's a bit of back and forth here, which I guess may be interesting or not interesting depending on I guess what you think here. So you can check the revision history associated with the file, right? If you're collaborating with other people, you'll be able to see the different sort of changes that people are making in your group, for instance, which obviously is useful. There are times when you may want to roll back to a particular version, right? If things are not working in the current version, for instance, right? Anyways, other interesting things here is you can edit the notebook by cutting out cells or copying cells and pasting them. Very, very useful, right? If you want to duplicate contents in a particular cell, or if you want to reorder, right? Imagine you're working with a very lengthy notebook, right? It's so lengthy and complex, but you want to rearrange things. You can cut and paste. You can copy and paste things, right? Which is quite useful as well. Also, you can find and replace, right? Again, a classic example here is you're collaborating with other people and you notice that they are not conforming to your agreed standard in terms of how you're naming, I don't know, it's classes or functions or something or variables. All you do is you can find and replace, is it? Yeah. The usual stuff associated with your typical edit functionality, right, in an application, right? A whole range of things here. You can clear output. This is my personal favorite. There are times when I want to share a notebook, right? Like what you're seeing here. If I want to share this, but I don't want to share this together with output, what I can do is I can just come to edit and just say clear all the output, right? So what I'll remain with is just a code construct. So that if I share this with somebody, all they'll have to do is, again, use, I guess, the runtime, the runtime menu item and just say run all the cells. And all of the cells are going to be run on their side, and then they'll be able to regenerate my output, if you will. I don't know why this is not running here. I think there's an error up there, so it terminated. You understand this? So the usual things here. So the most useful thing, menu items, you're probably going to want to familiarize yourself with the file menu item, right? Because you want to download this notebook so that you can work with it locally at the bare minimum. What else? You want to familiarize yourself with the runtime menu item because the instances where you may want to change the type of runtime or run all cells. You may want to reset the session, right? If you run into some unexpected errand, your cells are not executing. The easiest thing to do is you just restart the session, right? You're canceling, you're starting from scratch ideally, right? Or you can restart the session and run all the cells, right? Or you can say, I want to change my runtime type. There are certain things, like for instance, if you, I'm working with a group of students who at some point are supposed to be playing around with OpenWhisper or something, right? And it turns out that when you're using framework like OpenWhisper, for instance, just using default CPU here is not really going to be in your best of interest, right? It will take a long time. So what you do is you change the runtime, right? So you use the GPU here. I'll have to check. I don't know if your UNZA assigned email addresses give you access to these premium features. So these are disabled here because for me to use them, I would have to pay additional units ideally. I think though I probably have access to this in my Google Workspace because it's paid for. Let me just check here because it's a paid for account, right? And these days, I mean, these compute resources are not really that expensive, to be honest. Am I still logged on? I think I am. I'm just curious because I haven't really checked. No, it's not. I have to pay. I have to do this separately, I guess. And check this later on. And so you may want to play around with this, right? And stuff like that. What else? I think that's just about it, right? These are some of the useful things that you will find yourself using in the interface as you are constructing or editing your notebook. This toolbar here has features that are available in your menu items. It's just like your Microsoft Word, right? You know how the operations that you perform using these menu items and sub-menu items can actually be performed using your toolbar, right? If I do insert here, I can insert a code cell and a text cell, but I can also use this toolbar here, right? And just use this button here, right? To insert a code cell or insert a text cell. If I want to run all the cells in my notebook, I can just use this button here, run all, right? Is it? I can use this drop down here to specify the fact that I want to clear outputs. But the other option I have here is I can gain access to similar features from right within these menu items. Okay, so quite a bit of stuff here. There's the menu items and then your toolbars, right? Everything, all the changes, explicit changes as they relate to the textual content, visualizations, the code, the scripting takes place in this content pane. Okay, when you actually insert new cells, code cells, and text cells, ideally. And then when it comes to Google Colab, there are other additional things that you want to pay particular attention to. And I want to draw attention to there's a button right in this vertical menu panel here, or pane, which allows you to gain access to files. Okay, so if you click on this files button here, it's going to contextualize this panel here, right? This files panel. And from within here, you have access to some really interesting things, right? Interesting because when you're working on a data mining project, the primary ingredient is data, okay? And because the primary ingredient is data, the obvious question to ask is, how do I link whatever data I'm working with my notebook? Well, it turns out that there are a couple of ways of doing this. Two primary ways, actually, right? When you're using Google Colab. Yeah. So the very first thing, intuitive thing for you to do is you can upload the file. So if let's say we want to start working with this come in playground here. If you want to play around with this file here, right? Because I can work with it locally by using Jupyter, Jupyter Lab or Jupyter Notebooks. But what if I want to use Google Colab? Well, I can upload this, right? So I will navigate the usual stuff here. I'll navigate to the directory that has my dataset, right? It's in Playground, and then I'll upload it. However, when you upload the file using this upload feature, it turns out that the data that you upload is only as valid as your session, its lifespan. Okay? And this is the reason why I'm getting this warning, by the way. You notice that I'm being told that ensure that the files are saved elsewhere, right? These runtimes files will be deleted when the runtime is terminated. So you only get access to this file when the runtime is active. All right, so it's active right now. What I can do is, if you've been following through with what we've been doing, what I can do is I can say oh, I'm going to use Magics, right? And I want to do a list here to see what sort of files I have in my current directory. And true to that, one of the files I have is this file that I've just uploaded, right? This CSV file. Okay, so if I have access to this file, then well, maybe I can check. I can check the type of file, the type of file, right? Using the file command, is it? And then it tells me, well, this is a UTF-8 encoded text file, is it? Right? Okay. If it's a text file, then I know that I can run other commands, like I can run the more command, or I can do cut, is it? -n, right? And maybe just do it here. Seeing is auto-completing, yeah, header, but that's fine, right? So I can actually inspect this file, and at some point here, I walk us through, key libraries like Pandas or something. I can import Pandas, right? And when I import Pandas, because I know that I'm working with a CSV file, plain text file, CSV, comma separated, with pipe symbols as separators, what I can do is I can create this, right? Is it? I can create a variable that's going to hold, right? A Pandas data frame that's going to hold. Come on. That's going to hold all the data that is in that particular file. This is a Pandas data frame, right? And we'll talk about Pandas. We'll briefly look at Pandas here so that people understand. And I can check what columns are associated with Pandas data frame. Okay, it's this. So, but the thing here is that if I terminate this session, like I'm going to come here and I'm just going to say disconnect and delete the runtime, right? Boom. I still have access to my notebook. However, right, if I come here and I start running these commands again, I'll import Python Pandas. It works just fine because by default, Google Colab has this data science centric libraries already pre-installed, right? Right within Ubuntu here. So I can import Python Pandas quite right. But observe, if I try and say I want to read this file, I'm going to get an error, right? And I'm getting an error because that file was only valid within that runtime. So you want to be very careful, right? When you're using data, or when you're uploading data within Google Colab, using this upload feature, right? This thing is only as valid as the lifespan of your runtime, ideally. I mean, if you have, of course, I mean, you can get away with this. That's fine as well. There's always Markdown, is it? You can add a comment here to say, make sure that you upload this file within the runtime itself. Go to files or something and click upload, the upload button, boom, right? And stuff like that. What else? Well, I mean, the other features here, after upload here, you can refresh files, right? If you are uploading or re-uploading files, you want to make sure that you confirm that these things have been uploaded, you can refresh. And then in addition to uploading them within the runtime, what you can do is you can actually link, right, your drive. You can link Google Drive to Google Colab. And so what you're doing is you are mounting, okay? So you notice here, if I come here and I click this button here, it's mount drive, right? You're mounting your drive. And the very first thing that you'll be requested to do is you have to explicitly connect the account associated with the drive that you want to mount. You understand the idea of mounting drives, right? You've done operating systems, is it? There's actually your mount command, right? Is it? You can mount, right? You can mount drives, right? You can mount the file system. So typically, I have you won't see this here, but I have literally right now, I don't know if it's special, but I have a whole range of thumb drives. I'm gonna plug it in here. I'm plugging it in. I don't know if it's going to be, because it's going to work. I've mounted a thumb drive. It's mounted here. This has Ubuntu though. That's fine, right? So I can mount the file system. This is a drive idea. This is what you're doing, right? If you've used Astro on Android, the idea is the same, right? You can mount, you know, your OneDrive or Google Drive from within Astro on Android. I don't know if you guys do this, but so you notice here, right? When I click the mount button, mount drive, I'm requested to explicitly permit notebook to access drive. Sure, it's the same company that is behind, or same entities behind Google Colab and also Google Drive, but you have got to explicitly give permission to this notebook to gain access to your drive, right? So I'll connect here. And then the usual, right? What's happening here is because I'm logged on using my UNZA assigned email address, the drive that is linked, the drive that has been mounted is associated with the account lighton.phiri at unza.ac.zm. It's a part, right? It's a part where you want to, you know, when you're working on your project, it's a part where you want to be very careful what sort of accounts you're using, right? Because it turns out that when you're using your UNZA assigned email addresses, you actually have access to a lot of resources, okay? In my case, my account, if I go to Drive, and for this to make sense, I'm going to be context switching from Drive to Colab. So I'm going to yank this out like this, blow it out a little so that it's more visible, like so. And then I'm going to go back to Drive here. I'll be context switching, right? What you notice is that, so I'm here. What you notice is that I have access to 500 gigabytes of storage. You know, and for me, this is a huge plus, is it? Because there are instances where I'm working with large data sets, especially if projects where we've been working with images. These are like large data sets, right? So running them in Colab makes sense. And when you're using Colab, I can't be uploading medical image files every time I want to use them. I come here and I click on upload. It just doesn't make sense. What do I do instead? Well, I mount my drive. And I've mounted it. Now that I've mounted it, right? If I do an ls, what you begin to notice is in addition to, I don't know if you can see, I'll do an ls minus L here so that they're listed in one line or something, right? What you notice is that there's this file that I've uploaded in my session, CSC file. So, and surprise, surprise, there's this directory, is it called drive? We know it's a directory because this is an Ubuntu operating system I'm running these bash commands on. And when you list files, right, if you remember 2202, actually, a regular file has this bit marker here is a hyphen, right? A directory is a D. So we see here that there's a directory called drive, there's a directory called sample data. But also in the files vertical panel here, you notice that there's drive here, there's sample data, right? And there's this file as well. And obviously the icons here kind of give away the fact that this is a directory. So I can expand, I can collapse this, is it? I mean, I can expand this. It's collapsed, I can expand it. And then you notice that when I expand, I have access to two subdirectories, right? My drive and shared drive. Now here's the thing. The reason why I'm seeing my drive and shared drive is if I context switch to the Google Drive interface, right? Here, you notice in this vertical panel that in Drive, right? I have access to these things here. My drive, right? Which is a directory with subdirectories. And I also have shared drives, right? If you're using your personal Gmail account, you will not see shared drives. Unless if you're using Workspace or something, Google One or something, right? Or if somebody has created a shared drive and they've probably added you or something. Or if you're using your CS account, you can create shared drives. You know, you want to look up why should I use a drive, right? Why? Well, Lighton creates a shared folder using my drive, and Lighton's account, Lighton dies or something, and then the account is deactivated, right? That folder dies, right? But with a shared drive, it's going to be maintained by all members of the drive, if that makes sense. I don't know here. So somebody says, will our departmental Gmail account still be active after we graduate? I think the policy at UNZA is that they deactivate accounts when you graduate, when you leave UNZA, or when you graduate, right? I'll ask those of us that have microphone activated. I think it's Sekano. I don't know if it's no Boomba or something. Do you want to mute your microphone, please? Thank you. But I don't know about students, right? The department, I'll have to ask the system administrator for that. But I think they may they may deactivate accounts. And so my advice to you is, what I normally do myself is when I'm working, because I'm not going to be at UNZA forever, right? I'm working using my UNZA assigned email address, right? What I do is most of the drives that I create, right? I have a whole range of shared drives here, right? Projects I work with students and staff, right? In all of these shared drives, I will add my personal account because I will always have access to my personal account. So I'll add my kind of like, personal account so that I still have access to this information. It's a way of kind of like backing up, but there's other ways of replicating, right? You have OneDrive and all those things here. I don't know if this is kind of making sense here. Then there's a question here. It says, sir, does this mean if we link the Google Drive to Google Colab files instead of uploading, we can face runtime issues? Or does no, a session does not persist, and I'll showcase that example just now, right? But what I was, and we'll get to that just now. But what I was trying to put across here is that what you are seeing here in Google Colab, you see this is Google Colab, right? This is exactly the same as this, right? Again, I have access to my drive and shared drive. The only difference here is that my drive here has a space, is it? My space drive. Whereas in here, spaces are removed, right? So if you do in here, I'm in content, I'm in /content. Within /content, I have this file that I've uploaded in my runtime, and then I have these subdirectories, this drive and sample data. I can change directory into drive, right? When I change directory into drive and I do a present working directory, from right here, I change directory into drive and then I do a present working directory. I don't know why this is, it appears I can't, I don't know why I can't, maybe I'll have to do a content. I have to explicitly do this horrible stuff. Right? Change directory into here and then do a present working directory. Not working, I don't know why. Horrible stuff. I have to look into why this is not working. I guess, I don't know, but you can actually, I have to check why you can't, maybe if I get access to Ubuntu or something and start interacting with the shell from within Colab, this would work. But what you can do is you can still, even if you can't change directory, you can still access files here, right? If I do a file here, it will show me that this is a directory, right? And we'll come back to how exactly you access the files, right? So if I expand my drive, boom, I have access to subdirectories that are in my drive, right? And it takes a while here for these things to appear, right? Which is fine. And you notice that the files and the regular files and subdirectories that I can see here are exactly the same as when I'm in drive here. They are here, exactly the same. And because the way I work is when I'm teaching, I always create a folder in my drive called teaching. And then there's a subfolder called the year, in this particular case, 2026. And then there's a subfolder, which the naming convention is miscellaneous -unza -DCI for Department of Computer and Informatics and then I have the course code, right? So the folder associated with this course is here. And it turns out that for me to get access to this, I have to just scroll down here, right? I'll scroll down and I can just expand teaching. And then I would expand the year or something, 2026. And then I would go to this folder here. And then there's a datasets folder, which I'm going to use as an example here, datasets. Now, what I want to do here, right, to try and answer the question that Ms. Nyenda just asked here, is I'm going to say within datasets here, and there's nothing to see once I expand here because there are no subdirectories, right? But within datasets, if I want I want the data set that I'm working with to persist. In other words, for it not to vanish or to be deleted when my runtime is disconnected or something, or if it terminates, what I can do is I can go to, or what I need to do is I need to go to Drive. In this particular case, I'll go to the datasets directory and upload the file, the dataset. Right? So the usual stuff, right? I'll go to my local machine and then I'll just upload this file here. Boom. Once I upload it, right? Once I upload it, I'm gonna wait for this to upload. It's done. Once I upload it, I will then go to Google Colab, and Google Colab should be able to show me to say, hey, listen, if I expand this and refresh, I guess, listen, there's this CSV file that has just been uploaded. Now, this file here is going to persist. The only way it will not be there is if you delete it. So every time you mount your drive in Colab, this file will always be there. So there's a cheap trick here. I mean, you can kind of like infer where this is located, right? If you've been following through, I said in Drive, I have teaching, I have 2026, and then I have this directory here, right? Here. Because I use a kind of, what I do myself is I use the same naming convention myself. I use the same naming convention. It's usually a lot easier if I'm Drive. I guess this is not working. It's supposed to be Drive and then teaching. There's Drive and then there's supposed to be my Drive here. Is it? Here. / my Drive. Remember in Linux, casing is important, right? So my Drive, this is a directory, right? And then I have datasets, right? So what I can do here, from here is I want to list everything that is in that datasets directory, right? And I will see that that file, that regular file here, this. And if I can see this regular file, then, and the trick here is you need to use absolute paths, right? If I can see this regular file, then I can actually gain access to it, is it? I'll come here and I can say, I want to view it, right? I'll do more, then I want to see this file here. And then I will see the contents of the file. So it persists like that. Okay, but there's a way of getting around this. You don't have to, the reason why I'm able to figure out the exact absolute path of this is because I use a consistent naming scheme, right? So I know exactly where to find these files. What you can do is, as you are, kind of expanding, right? Expanding the subdirectories associated with wherever your regular file is located. Once you find your regular file, like in this particular case, it's here. What you do is this menu item, you just click on these 3 vertical dots, you say hamburger menu item here, kebab, and then you say copy path. When you say copy path, what you have access to is the absolute path to that file, right? If I come here and I want to copy the absolute path of datasets, I just say copy path, right? And then I come here, I paste, it will be the same exact absolute path. And it's going to be useful here because when you're referring to the things that are in Google Drive, you need to use this absolute path. If this is making sense. I want to showcase something here, right? We want to delete this runtime, disconnect and delete the runtime like we did before. And what I'm going to do is I'm also going to clear the output, right? So that we don't have this output. Now observe, I've deleted this runtime, right? And right now, if I attempt to run these commands, like I want to view the file here, right? This will not work, is it? It will not work because when you disconnect the runtime, the things that you'd have done before, if it will work, maybe it will work, maybe it won't. I don't know. I have to check. I think it's already mounted. I think it will. I don't know if it will work or you have to remount or something. Okay, it will work here because implicitly, if you notice bottom left here, this thing is being mounted, right? In some instances, it may not work because you need to mount the drive first. But in this particular case, this thing knows that this file is in my drive, so it's mounting, right? And you notice something. I've deleted the runtime. The file that we uploaded here has disappeared. However, the file that I'm accessing within Google, what do you call this? Google Drive is still there. It persists, right? And you want to appreciate this, right? You want to appreciate this. The other thing that you probably need to appreciate is the fact that if I share a notebook with you, and I'm making reference to things in my drive, obviously, because you don't have access to my drive, it won't work, right? So one of the things you'd have to do is you change the paths that are going to be relative to wherever it is you're storing these, wherever it is you're storing these data sets. Okay, I don't know if this is making sense. So I've done a couple of things in the past here, like I want to show you an example of acknowledgement text. There's a project I think I used as an example where I was making mention of the fact that acknowledgement. I was making reference to the fact that we were harvesting PDF documents of ETDs and then analyzing them. Right? These are a lot of documents, right? A lot of documents. And I'm going to showcase to you here because do I have access to? I'm surprised that I can't find acknowledgement texts. I'm surprised that I don't have acknowledgements text here. PDF. I know I have, I should have acknowledged. Or just say 1, 2, 3, 4, 5, 6, 7, 8, 9, something. I'm looking for specific files that I want to use as an example here, but looks like I won't be able to. It's not a file that I'm looking for here. I'm looking for any type of file here. Or something like that. I need a PDF, I guess, is what I need here. Or something. I'm trying to demonstrate something, and this is what I wanted here. So we harvested kind of like PDF documents, right? Now, the thing about these PDF documents that we harvested, and I want to showcase this here so that I don't know why this is not showcasing what I exactly want to demonstrate here. Or is this going to be expanded? Okay, so it's expanded by default. So this is in research, and then in 2024, so it's in research, and then 2024. I want to showcase something here to you, right? I'll go to research 2024. See, a problem here, it takes a while to load, because it's literally loading everything in my drive, right, and my shared drives, and I have a lot of things. So I'll go to research. I want to demonstrate something here. I'm trying to provide context or motivation for why you would want to use Drive as opposed to this, right? So I'll come to JCDL 2024. which is wow, here. And then I guess datasets, yeah, datasets, and then I'll go to PDFs, right? Now here's the thing, right? We have like we have this dataset here. Imagine what you would have had to go through if you needed to, and I guess I should do this in datasets, I guess. Imagine what you'd have had to go through if you were doing this on a local machine, right? It's a whole lot of files, for one. It's taking a while here to demonstrate. Let's just wait for the output here. It's a whole range of files that are here, right? These PDF documents here, a lot of them corresponding to PhD and master's dissertations or manuscripts, thesis and dissertations, right? And we're doing a whole range of things here, you know, unpacking the PDF or reading the PDF to check where the acknowledgement section is located. I don't know why this is taking a while here, but also I can do a BU max depth or something. Then I'll do this as well. I want to see, or I should have done it to dataset or something. So there's quite a bit of this. This is a massive dataset, right? And obviously, if you look at it from the perspective of real world problems that you'd be working with, obviously this is nowhere close to massive amounts of data that you'd find yourself working with. But still, the point I'm trying to put across here is that it's usually advantageous when you're actually doing this, right? It's usually advantageous to use cloud-based storage ideally. Now, of course, when we talk about ethical consideration, you know, the important, you know, discussions we're going to have as they relate to the implications, right, of doing some of these things. Like, for instance, if the data we're working with has personal identifying information, you are legally not allowed to upload data on Google Drive, right? I don't know why this thing here. I'm gonna just restart this and run ourselves. You're obviously legally not allowed to actually do this. There we go. See this? You're legally not allowed to do this, right? To use Google Drive, because the servers you're using are not located in Zambia, is it? Is it? What we're doing here is a clause in the Protection Act. I do a ping to Colab, you know, .research.google.com. Things are not in Zambia, is it? Or if I do a ping to drive.google.com or something, these servers are not in Zambia, right? So, I mean, we're doing the wrong things here, right? We want to be able to do this. Is if you remember your networking, right? The basic networking, right? These public IPs here give away which part of the world the server is located in, right? So we know this is Zambia. If I try and ping my alma mater, for instance, you notice that the IP address is specific to South Africa or something like that, right? Remember that. But anyway, so this is what I wanted to demonstrate here, right? So if we do maximum depth, I'm going to just do in dataset here. It gives you an idea, right? I'm doing this, right? I'm doing this. This gives you an idea of how much data we were working with, right? So the files, the total files that we downloaded, the PDF files cumulatively, in this particular case, right? It's 16 GB of data we are processing. That's a lot of information, right? If I was doing this locally, it's like, okay, yes, I can do this locally, but then you sit and you're reflecting. There's so much going on here, because in the original notebook, we are downloading files, we are processing the files, right? For each file, each PDF file we download, we process it, right? So it turns out that using cloud storage makes life relatively easier, right? But of course, I mean, we can do other interesting things here, like count. How many files do we have, right? Or we can do a list. Okay, I don't want to do a list. Maybe we can do a list. List all the files in here, those PDF files. There's a whole range of them, right? They're all going to be listed here. All of these PDF files, right? Well, okay, how many of them are there, right? I'll just do a WC or pipe. Well, we see here that there's probably a few thousand, 4,480 PDF files that we are processing. Okay, so hope this is kind of like making sense here. The long and short of it here is I'm trying to hint at the fact that it's in your best interest to use Google Colab in 4792 at least, right? Why? You're collaborating with other people, so it's a lot easier to collaborate with other people. B, the data that you're going to be processing in your respective projects, and by the way, by end of next week, I'll share the topics. The data that you will be harvesting and processing, it turns out, may require that you revisit, right? You reharvest and reprocess and all those things. So using cloud-based storage becomes advantageous in that particular case or instance or something. Okay, I see there's a question. Does it mean the file format for the data matters? Not really, it's contextual. So what you'll notice is almost all the use cases we have, the two data sets we're going to be using are going to be CSV files, comma-separated value files, plain text files, right? But there are instances where you're going to be processing. There are instances where you will be processing images, right? So PNG, JPEG files, SVG, right? Those of you that are probably working on image-centric problems are probably already doing this, right, in CSC 4004. Or you can work with audio, right? I work a lot with audio, usually when I have meetings, the easiest way to understand what has been going on in case I miss out the things that I'm noting down is I'll just use Open Whisper, right? I use Open Whisper to generate, minutes or something for my own consumption. It's usually useful, I guess, like that. I don't know to what extent people find that useful, but it's useful for me. In that particular case, I'm working with MP3 files, right? So what I'll do is typically the file that is generated by this application, OBS, is MP4, right? It's video, right? So what I'll do is I'll get this file here, right? Literally at the end of this, and I think I don't know if I've demonstrated this. I think I have. I don't know. In case I have, apologies, I'll repeat this. I'll use it as an example. But what I'll do is I'll use, I get the file. It's still recording, is it? It's streaming and then it's dumping a local file on my machine as well. So what I'll do is I'll use FFmpeg, right? I don't know if people use FFmpeg. There are wrappers for FFmpeg. If you work with video files, obviously, you use FFmpeg, right? Incidentally, if you use video processing software like Kdenlive, for instance, what if you do any sort of video processing, right? Which I do, not serious though. But what you do is implicitly you're using FFmpeg, right? Very powerful application. So what I'll do is I'll use FFmpeg, and in fact, I can even show you a history, right? If I just grab for FFmpeg, you notice that recently I was doing a whole bunch of things with FFmpeg, right? And stuff like that. So I'll use FFmpeg and the typical command I'll use is literally this here, right? So I'll use FFmpeg to say, can you convert my MP4 file to an MP3 file, just audio? And then I use the audio as input, Open Whisper, to do a speech-to-text conversion, right? So I'm converting the audio to text. And then, the interesting analysis is done on the text itself. Okay, so in that particular case, you're working with MP3 files. What else? I just use an example of PDFs, right? You may find yourself working with video files as well, right? Like MKV, or in fact even MP4, right? If you remember, one of the examples I was highlighting was this pothole detection problem, right? Where I showcased that what we're doing is we're actually analyzing video footage, right? That's literally MP4 and MKV files, MP4 actually, because my dashcam literally generates MP4 files, right? I think I have examples of logs here. Let me just check which one. Just going to get to I don't know, Chisali should be interesting or something. Was this push to Chisali? Yeah. Push Chisali. So my dashcam generates. It generates the thing I have mounted in my vehicle. It generates these files here. Generates these files here. It's MP4 files, right? So a file like this, and the way it does is it's configured to generate these. It generates. Notice here, right? This is an MP4 file, is it? Right. So if I open this, you'll see here. What it does is it generates these things. Literally, it's. Do I not have VLC here? What? This is a thing. You know, guys, I hate. I should say this. I hate Snap, right? I hate it so much, but I'm forced to use Snap if I want latest versions of files. One of the reasons I hate Snap is because now I can't run my binaries the way I normally run them, right? It's stupid. But so this, what I was talking about here is this, is it? Just gonna copy this. Ooh. Right. So this MP4 file, MP4 file, right? This thing here. You can literally build applications that are do fancy things to your video files, right? But all you're doing really, if you remember the stuff I was showcasing last time with the portal detection, all that's happening really is you're creating overlays, right? What I mean here is, I think you know what I'm talking about. That portal detection thing. These are just overlays, right? So you're running the model. You build a model that does the portal detection, and then behind the scenes, what's happening is that you're generating a completely new video file, right? Excuse me. What you're literally doing is this is what I mean here. This thing here. These are annotations, is it? So it's like you run a model, but you pass the MP4 files as input. What happens, and this is a feature within YOLO really. If you've played around with YOLO, you know what I'm talking about. What happens is you can specify it. So you want the output to be a video file, right? It's going to be an MP4 file again. But the MP4 file is going to have annotations as they relate to whatever model you're using or something like that. And there's nothing complex about that also. Okay, so that's kind of like Google Colab, right? I'm gonna pause here and maybe just ask if there are questions about Google Colab. And my expectation is that going forward, when I share a notebook, right? If I share a notebook via Google Colab, you should be able to make a copy of the notebook, right? For sample code, you make a copy of the notebook, and then you make the appropriate changes, upload the files in whatever location in your drive you wish, and then the rest is kind of like history, right? My advice to you, though, is, but obviously I don't know. My advice to you is that you want to make sure that you use your UNZA assigned. Where am I logged in here? This is personal. I'm looking for. This is my. Yeah, this is my. This is my. My workspace, I think. This is my workspace. This is what? This is main UNZA account. So, and then this would be my CS account, which is here. So my advice to you is you want to make sure that you're doing these things using your CS account, right? In fact, some of the assignments require that the changes that appear should include your personal CS account. So you log into your CS account like I have done here, right? Like so. And then from here is where you'll be running your Colab with research.google.com. Google.com. So that when there's an assignment that says submit Colab.research, if there's an assignment that requires that you submit a notebook, what you want to do is you want to make sure that you're using your personal email. You're using your CS account. Okay. What we want ultimately is, and I'm going to showcase an example of what we were doing last year, I guess. What we want ultimately is something akin to to this. I just need to collapse some of these things here. I can go to teaching, I guess. I want to go to last year or something. I don't know if I'll be able to find. I think I should be able to find these things. I guess, I don't know. Want to be able to group assessment. I'm looking for the code here. I know it was being graded here, technical reports, code, there we go. I want to show you something, right? So if you have team one, I don't know if team one did what they're supposed to do here. I don't know if there's a notebook here. Horrible. Following instructions sometimes, not sometimes, I've come to learn is a problem for most of these students here. I'm going to use this as an example. If I open this notebook here, if I open this using Google Collaboratory, I want to show you something. Well, one of the things we want to see is collaboration, right? Intergroup collaboration, for instance. So that if I come here and I check, oh, come on, this is a horrible example as well. Only one person was creating this, right? Always happens. I can't remember, there were a whole bunch of groups here. I'd have to check my records to check the best performing students, I guess, to demonstrate people that were actually doing the right thing, right? Don't know, maybe, I think Dave's group was I don't know, it was random here. I found Moisa's group here, comprised of people that were clearly aware of what was happening here in some tremendous way. But I want to demonstrate what some of the things that we're going to be interested in. You have to check the horrible, disappointed with even David's group here. But anyway, so the idea is we want to be able to check all of these things, right? The changes that are happening and stuff like that. It's a pity I can't find the Albert Nisa's group. It's a pity I can't find what I need here. I don't know if this is the one. Okay. That's neither here nor there. I guess, I don't know. I don't know if there are any specific questions that you guys have or something as it relates to, this is a horrible example as well. I can't find a better example from either one of these guys. But I know there are some people that were clearly doing the right things here. Some people that never even submitted, but that's okay. I'm not complaining. It's neither here nor there. Okay, but you want to make sure that you're using your UNZA assigned email address, and I'm here to check here. I don't know our CS accounts, how much space I have access to. I've become overly dependent on my UNZA assigned email address because I have a whole bunch of space there, 500 gigabytes, which is tremendous. I can't even check the maximum space I have access to in here. I don't know if it's unlimited, maybe not. All right. Are there any questions associated with today? I think we can probably kind of leave it at that today, I think, in my opinion. We were supposed to have a session on Monday, but the day after tomorrow is a holiday, apparently. So there's a bit of a problem there. This thing was not streaming, which is horrendous. It's lying here. It's horrendous. But we're supposed to have a class day after tomorrow, but it's a holiday, so our next class is going to be on Thursday. Maybe actually still a bit of time here. If there are no questions, maybe we can just briefly have a sense. I think we can. 15 minutes is a lot, although no, it was not really supposed to be. It's 45 times 2 here, which is 90 minutes. But yeah, you guys, what are you doing on Saturday? Nothing. Okay, it's okay. We can do this, I guess, when we meet next. So what comes next? I'm just going to give you an idea of what we're going to be doing next. The next time we meet, right? I mentioned that we're going to skip part 2 but I've left part 2 in its entirety. There was quite a bit of content here. It's meant to be like an introduction to Python, and what I did was I cherry-picked the things that I will use as I'm demonstrating the practical aspects of the topics we're going to cover, right? So things like functions, there are no classes here because that's a bit overkill for us. This is not an introduction to Python course. It's data mining and warehousing, right? So we're really interested in the bare bones of Python. The most, in terms of code constructs, we're going to find ourselves using here is functions. That's it, right? We're not constructing classes and all those things. So anyways, so there's quite a bit of content. Some of you may find this useful, but you'll find me using functions, list comprehensions quite a lot, right? And there's a specific way I import modules. Usually I use a conventional way of doing this, right? So if you see me do something like, and as a way of recapping what we're going to be doing going forward, if you see me doing something like import, if you see me doing something like, and I think you've seen me do this, I did this, right? I at some point I said import pandas, import pandas as PD, right? I mean, this allows me to do a pd.read, right, under by CSV, or read under by HTML and stuff like that, right? However, you know from your programming language paradigms that when you're working with modules in Python, it turns out that you can also import, you can just import this pandas library by just saying import pandas. This works. However, what you're going to have to do here, they told us, is you're going to have to do pandas.read CSV, right? So you have access to this, right? It's there. It's a function. You can check the objects that are in here, yeah, right? So can you do, when you do import PD here, like so, you can also do the same thing. You can do dir, or you can do a type PD. It will show you the same exact output as before, right? It's a module. And then if you do a dir, you have access to the same sort of things as well. Okay, but the only difference here is the implications, right? If you do import pandas, then every time you want to it's supposed to be dir pandas made Python like this. Every time you want to kind of gain access to an object within the library itself, you'd have to use pandas dot, right? So it's a choice of doing either pandas dot, like if I want to read CSV data, right? Pandas dot pandas dot read CSV, or PD dot read CSV. Now, what you notice that, oh, but I use a lot of PD. Why is that? Why am I using PD? Well, because by convention, this is what people do, right? The average tutorial that you find out there on the internet will use this convention. The same applies to Matplotlib, right? You find me doing something like from Matplotlib import pyplot as PLT. I have to do an as PLT, use the alias to import, right? I could just say import pyplot, right? And then just do a import pyplot and stuff like that. Or better yet, so what I mean here is better yet. So in here I can say import matplot from pyplot, right? Import from matplotlib, import pyplot as PLT. This will work. But guess what? So we'll import matplotlib from matplotlib import pyplot without the alias, like this. This will work, right? Also, I can just say from matplotlib, like this. Look at this. Matplotlib dot pyplot. Import everything, right? This works as well, right? The only issue that is there is that this has implications in how you are calling these objects that you're interested in. In this particular case, I've got to use it, like in this, if I want to plot, guys, pie chart, plt.py, right? This will work, right? The function. I can also do a pie plot .py. This will work. It's a function as well. I can also use, because this last one here means I've just imported everything that is in here. So I can directly refer to these functions, right? Without using the dot operator. But people will tell you that this is confusing, is it? Because it becomes difficult to distinguish user-defined constructs from those that are associated with whatever libraries you're using, if this is making sense. So this is what you will have in the slides. They are meant to be upgraded, and I was taking into account the fact that I needed to be as concise as I could possibly be. And so brevity was very key here. But yeah, so afterwards, when we meet next time, we're just going to have a very gentle introduction to the key libraries, especially those that you find me using in lecture series. Is it number 3? Beginning lecture series number 3. We'll start using some of these libraries. So I wouldn't want you to get lost, right, in the source or something. So we'll look at Python pandas, we'll look at the datasets. I'll introduce these datasets when we meet next. And then we'll look at the libraries. We'll start with Python pandas, take a bit of time looking at Python pandas because it's quite key to most of the things we're doing. And then we'll look at how we graph using Matplotlib. And then the other core libraries like scikit-learn, we'll introduce them when we look at clustering and classification, which is probably going to be next series number 5 or 6 or something. Okay, I'm going to pause for now. This is 6:52, and ask if there are any questions. If there are any questions here. Faiza, no need to signal that you're in attendance. I have access to class attendance, literally. It's right here. And, they're all here, right? Faiza, I don't know what. Oh, but you've only been in attendance 1 minute. No, Faiza, right? You've only been in attendance for 1 minute. It's probably going to be like 2 minutes or something. Well, a couple minutes, I guess. You are in attendance from 6:47. Sorry, that's like implicit naming and shaming here. Yeah, take this into account, right, for awarding marks here. Same as Guba here, right? Guys, what's going on here? Okay, are there any questions, thoughts about this? If not, some of these things, right? If you don't remember your Python, my advice to you, right, is, because we're not having class on Monday, the next time we're having class is Thursday. Find time. This is a long weekend, right? Don't go wherever it is people go on 4 days holidays here. Well, at least carry your phone and your laptop, and when you play around or something, you do a bit of revision, so that when we start the actual hands-on type stuff, you're not going to get lost, right? You don't want to get lost. So there's that here. I don't know. This person is saying, how about the exam? What exam are you talking about? See, Senate said they will announce. They haven't made an announcement. Have you been to campus, you guys? What exam are you talking about? Okay, guys. Yeah, but yeah, you can still study. Have you been to campus here? Who says this? When are the exam? But okay, I don't want to say anything. Guys, I'll see you when you see me. So yeah, you want to go, if you're in town, go to campus and see what's there, right? I don't know what you're talking about. Okay, exams here. Thank you very much, and enjoy the rest of your Saturday. Please do a bit of Python programming and review, so that you're not lost here. Good day, or good night, or good evening. Thanks.
Ah, que sí, paisaje de